Very often, industrial companies define formal phases for their projects. Each phase has a gate in which the continuity or abandonment of the project is decided. Let's take a look at these phases. As mentioned, industrial companies define formal phases for investment projects. This graph is just one possible example, as each company may have its own criteria for dividing projects into phases. Each one of these phases represents a specific portion of the investment, with increasing levels of detail in the project definition. This allows for the establishment of gates, where the executive team decides whether to continue or abandon the project. It is important to note that these gates are not just review points or project status updates. They are critical decision-making meetings where executives determine whether to proceed or cancel the project and how to prioritize it against some other company's initiatives. Now, let's take a closer look at the content of these phases. The concept appraisal starts by recognizing unmet needs of a product or service. This phase, called visualization in other project management models, is where the idea of the project takes shape. The goal is to identify opportunities, define the overall vision, and establish the purpose of the project. Key activities include problem identification, for example, understanding the challenges to be addressed, preliminary feasibility analysis, and preliminary stakeholder analysis. Feasibility analysis allows you to estimate the cost-benefit before deciding to invest in a specific region, area, or sector. Multiple variables are analyzed for this purpose, such as market demand, construction cost, interest rates, and estimated schedule for the project. Next phases continue if and only if this analysis is favorable. The next phase is conceptualization or concept development. Here we delved into the technical design, cost estimation, and financing mechanisms. Let's look at some of the key activities carried out in this phase. In this phase, different techno-economic solutions are explored, finally selecting the one that appears to be the most convenient according to the project's constraints. Conceptual engineering is carried out, as we will see in a later lesson, defining key elements such as the main process flow. These serve as a foundation for further refinement in detailed technical designs during later phases. As we have mentioned, in this phase the engineering team go deeper in time and cost estimations. The Association for the Advancement of Cost Engineering establishes a standard classification of cost classes. In increasing order of uncertainty, Class 1, for example, has less uncertainty or higher precision than Class 5. Companies define the required level of accuracy or cost classification for each phase of the project. The concept development phase is generally declassified as Class 3, although Class 2 may be required for key equipment that could have a greater impact on the project's total investment. The project risk assessment is also explored in greater depth, focusing on events or conditions that could negatively impact the scope, timeline, cost, or quality of the project. The process begins with risk identification, covering both internal risks, such as planning failures, and external risks, like changes in regulations affecting the project. These risks are then evaluated and prioritized based on two key factors: likelihood of occurrence and impact or consequences if the event happens in the project. Naturally, greater attention must be given to risks with a higher overall score, meaning those with both high probability and high impact. Both risk mitigation and monitoring of potential negative events must be continuously reassessed throughout the entire project. Once the conceptualization phase is reached, the owner must structure the financial support to ensure that the project can be executed. There are many different scenarios when it comes to funding. It is common to propose mixed solutions in which the direct contributions of the owner are complemented by loans from financial institutions, direct participation of new investors, capital increases, or a wide variety of other alternatives. The next phase is design and documentation. At this stage, all design documentation is developed in enough detail to enable the construction and assembly of the industrial plant. This phase is divided into 4 key activities. Scheduling, a written statement outlining all activities and requirements for the engineering, procurement, construction, and commissioning stages. In addition to a detailed task plan, it includes descriptions of the services to be used, spaces to be occupied, and interrelations between project functions, among other details. Schematic design. The designer creates preliminary site plans that illustrate the relationships between various functional areas. Design development. The project team produces detailed designs for all equipment involved in the plant, along with their intercommunications. Construction document. This includes specifications and drawings that serve as the basis for bid requests and for the actual construction and assembly of all components. We have described the initial phases of industrial projects. But before moving forward, it is important to remember that in addition to phases, the model also requires gates. These gates are strict decision points where the project owner can choose to proceed, pause, or abandon the project entirely. A phase development model cannot function properly without these rigorous control points. At the end of the detailed design and documentation phase, there is a particularly significant project gate, known as FID, Final Investment Decision. Once this gate is passed, the project officially moves into the construction phase. Companies typically enforce very strict criteria before approving this final investment decision, considering factors such as expected profitability, assumed risks, demand estimates, and more. Finally, we have the construction phase. This is the most capital-intensive phase and involves the most physical work on site. It is heavily influenced by the concept development and design stages. The higher the quality of deliverables from those earlier phases, the fewer unexpected issues will arise during construction. The construction phase can be divided into 4 key activities. Procurement, the overall process of sourcing and purchasing materials, equipment, services, and subcontractors needed for the complete execution of the plant. Construction, the actual field operations, where physical work is managed and coordinated. Commissioning, the process of verifying, inspecting, and testing every operational component of the project, from individual instruments and equipment to larger integrated systems and fully functional modules. Handover to the owner-operator. This final step includes the transfer of the facility to its owner or operator, followed by plant startup. It involves both highly technical aspects, such as hydrostatic testing of pipelines, and critical legal requirements, including insurance certificates and state registrations.